We've adjusted the heating, so that apparently it's not going to be quite so cold in this room. We've had a couple of people come in and going, oh, it's too cold, and left again. So we've put the temperature up a bit to see what happens. It probably means by the end of the session we'll be as far as not. Air control. So while we're slowly warming up or chilling, depending on the perspective, Paul is going to give us a talk on APIs, events, and streams. Over to you, Paul.
Thanks very much. So I'm the CTO and co-founder of a company called WSO2, and I sort of used to work for IBM before that as an architect. I think I have a slightly different mindset to some of you, so I felt quite out of place over the last. I really enjoyed the last talk about if you were here further constraints, and I'm a bit more in the bits and bytes, but I hope you find this enjoyable. I thought I would just give you the 1 minute intro to the whole talk, and if you don't want to see it, then you can just walk out. So basically, what I'm going to talk about today is that enterprises are disaggregating their architectures in order to scale and be agile. And those disaggregated components, I believe, need to have well-defined interfaces, which I'm going to categorize as APIs, events, and streams. And I think that without effective governance of those, you're asking for big trouble, and I see a big problem looming. And I think that this is actually challenging the layered enterprise architecture that I grew up building and we've all known. And I'd like to propose that a new architecture needs to emerge, or is emerging, which I'm going to categorize as cellular. So that's basically the talk. So if you're not interested now, or if you think, well, okay, I know it all, I'll go now, but no, you're all staying, that's good. So we've seen all these companies, Uber, Amazon, Google, everyone disaggregating their architectures and scaling to meet massive demand. And it's not just those. I have a lot more kind of traditional enterprises, and they're also doing the same. Everyone I talk to is saying we're going to a microservices architecture, we're looking at serverless, and so forth. And I actually see this as a continuation of a trend that's happened over 5-6 decades. You know, from monolithic mainframe apps to enterprise apps, departmental apps, SaaS. We've seen the APIs, and now we're seeing serverless and microservices, and this is all disaggregation. And what's really driving this is the need to be more agile and also to scale. And I think this is being accelerated by cloud, because what people find is that these kind of apps, when they deploy them in a cloud, are very expensive to scale. And they're suddenly getting massive Amazon bills and Azure bills, and then they're going, oh, we need to disaggregate further so that we can scale more independently. And that's really accelerating this picture. And this is turning the challenge of developing applications actually into the challenge of integrating applications. So Gartner is saying that by 2020, digital transformation will actually be 50% integration, because you've got all these components that now need to be integrated. And what's really interesting is that 60% of organizations are doing agile and say they've got broad adoption of agile, but no one's actually seeing that agile percolate its way up to the enterprise level. They still feel their enterprises are non-agile. And my thesis is that that is because the integration is not agile. So in other words, we're building little projects that are agile, but then to build an actual end-user digital experience requires integrating across multiple projects, and that integration is not agile. So this is a sort of a problem which I'm sort of characterizing as an integration agility gap. And I see this decoupling at the moment happening in really 2 dimensions. So we've seen increasing virtualization and decoupling from the physical infrastructure. So, you know, virtualization, cloud containers, Kubernetes, cloud orchestration. And we've seen functional decomposition with, you know, APIs and DLLs in the 80s when I started programming web services, SOA, APIs, and endpoints. And when you do those 2 things together, you start to become what a lot of people are characterizing as cloud native. So these are components that are disaggregated both in terms of function and in terms of the infrastructure, can be deployed independently in clouds. And that's taking us a long way, but unfortunately, I think that people are kind of going down this path without necessarily got the right control points. So as I said, you know, we've seen this big growth in serverless and microservices, which kind of fit into this trend. And it's the scale, agility, and the cloud economics that's driving this. So particularly microservices, what I see people having is they build a big infrastructure, they deploy it in Amazon, suddenly they start getting bills of $10,000 a month, and they're like, that's more than I expected. And then one of their developers discovers that if they refactor it all in Kubernetes and redeploy it, they can pack a lot more instances into the same infrastructure, and suddenly it goes down to $5,000 a month. And then some bright spark says, oh, if we make it all preemptible, we can use spot pricing, we could deploy it in different regions based on who's got the cheapest price, and we can preempt it, and the price goes down to $2,500 a month, and suddenly the business is quite happy. Maybe the architects aren't so happy because there's not been much, it's just happened ding, ding, ding like this. And I think one of the big challenges we have in this microservices architecture is there's no real abstractions, there's no real architecture planning and forethought, and we don't have the right mental models for how to think of these. We have some sort of simple rules, you know, microservices have their own database and their own data store, but they aren't really helping us as an organization get greater agility. I think if you talk to the CIO of an organization who's got microservices, I don't think they would feel that they had composable business building blocks that they could take to market. In fact, it's work. I mean, I know this guy, and he's the lead developer for a price comparison site. They've done exactly that thing I was talking about, going to Kubernetes, going to preemptible instances. They've got about 10 developers. They've already got 250 microservices. He's the lead developer. He doesn't know what they all are. They've got no registry. They've got no. All they have is the GitHub code repo in which they're in. So to me, we're already getting into this mess here. So I'm sure we've all come across this statement. I've heard it called the fundamental theorem of software engineering. All problems in computer science can be solved by another level of indirection. Interestingly, I found out that this is actually kind of a misquote from David Wheeler, because the guy who more famously quoted this, a guy called Butler Lampson, forgot half the saying. Because the original saying was, except for the problem of too many layers of indirection. Which I think is hilarious. And, you know, so APIs are one of the ways in which we form an abstraction or a layer of indirection. An API is a business capability delivered over the internet, network accessible, standard web protocols, well-defined interfaces, and designed for access by third parties. And you can sort of draw it like this. You've got some component that makes a network service available, and hopefully you have some description of it in a machine-readable format. And the most popular seems to be this thing called OpenAPI, which is a format called YAML, and that's something. But I think we need more than that. We need some governance and management. And so a managed API is something that's available and subscribable. It has SLAs, it has authorization and security and authentication, and it has monitoring and perhaps some monetization, but certainly a lot of analytics and visibility and observability of what's happening. And that's actually a much more complex picture, because typically the way people implement that is with a gateway that tries to take a policy from here and implement it. So that policy might be to do with the number of requests a second, might be to do with access control and key validation. There's some kind of keys that are required to access this, and so there's some identity management and policy. There is usually some sign-up and workflow for developers to sign up and use it. There's the description, there's versioning, there's human documentation, forums, SDKs, issuing of keys, and then there's a whole set of monitoring and tracing and monetization behind it. So this kind of gives you some governance and management of it. And that helps. I mean, we're still a long way from having a solution to the problem, but it helps a bit. The other thing that I think we haven't quite got to yet is the combination of push and pull. So APIs are generally pull. You're normally saying, give me some data or do something for me. And increasingly we're seeing that control of an API is not enough. That we also want to see notifications from that, which I call events. And I'm distinguishing between events and streams. So streams are when you look across APIs and events over time, and you start to get intelligence about what's happening over a period of time. And stream processing, I think, is an important part of this story. And what we're getting to is a world where you can see almost everything out there as an API, an event, or a stream. So devices, IoT, are basically taking the real world and making it into APIs, events, and streams. Of course, SaaS apps, internal applications. This is a big growth area where people are not using API management just to talk to third parties, but within their organization. Of course, external APIs, data, events. And people are beginning to notice that actually identities can be managed as APIs, events, and streams as well. So this is giving billions of different addressable endpoints. And this number is frankly exploding. I think it's not ludicrous to predict that in 20 years' time there's going to be trillions of endpoints. I think that's a very reasonable view of the world.
Sorry, those numbers are events.
No, so this is the number of devices that are connected to the internet. This is the number of SaaS applications that there are out there. This is a rough guess at how many internal APIs there are. This is how many external APIs there are, and so forth. So I'm trying to capture how many of these things are exposed as API streams and events today. So that fundamental of software, a theorem of software engineering, I think there's a corollary to that, which is that almost every problem comes from leaky abstractions. I think that's one of the biggest problems, is that we do indirection, but if we don't do it right, if we have a leaky abstraction, then it leads to a problem. And in doing 20 years of building large software products, I have found that almost every problem we've ever had has been a leaky abstraction. Every difficult problem. Of course, there's little bugs, but the hard bugs, the hard problems, come from leaky abstractions. And in my career, the thing that I use most, I'm mainly a Java developer, was this thing called OSGI. And what OSGI really gave us was the ability not just to expose APIs within a JVM, but actually to hide stuff, to try and constrain the abstraction and hide things. And that was really highly valuable, because it let us version things, it let us be much more modular. And I think this is one of the challenges in these microservices distributed endpoint architectures. The problem is just as much about hiding as exposing. So why use this architecture? I think I kind of explained this. APIs provide an abstraction over things that can be queried or activated. Events allow you to trigger things on notifications, and streams can capture the evolving nature of the environment, allowing you pattern matching and analysis. But I think this abstraction, although it seems lovely, is completely pointless unless we put in place the right governance. Because without the right constraints, without making sure those abstractions aren't leaky, this is just going to end us up in a big mess, and I think you can already see that. Sorry.
You keep saying leaky abstraction. What do you mean?
So a good example of a leaky abstraction is that, say I want to use a logging component that somebody else has written in my system, so that everyone logs in the same way. And that logging component has some interface that it exposes. And the interface is not well enough defined, or there's some backdoor you can call that you shouldn't be able to, and someone codes to that. And then 3 years later, we come up with a new version of that, and they've changed the behavior of it. They haven't versioned it properly. The contract between the people calling it and the people providing has somehow changed because they didn't expect it to behave in that way or be used in that way. And then they change it and everything breaks, or it breaks in some way that you can't spot, or you do a merger with another software product or another company, and now you're trying to all use what you think is the same logging interface, but you're using it in different ways. It no longer works. So those are the kind of things I mean by leaky abstractions. Another very good example of this that I've seen lots of times happen is where people actually code around bugs in the software. So I did a big project for a very large networking company, and they had decided to use a standard protocol called XMPP to do everything. So they agreed everyone was going to use the same standard protocol, but because they somehow didn't like to reuse available libraries, of which there were hundreds for this protocol, one group went away and wrote their own library for the protocol. But they got it wrong. They didn't read the spec properly, and they implemented something that they thought was this protocol, but they actually implemented the wrong semantics, the wrong wire protocol, everything wrong. And we all ended up writing software to support what we characterize as BXMPP, bastardized XMPP. Then that team got fired and left. That software was ditched, but 3 years later we were all still writing software for the broken version because of this screw up. And it caused millions of dollars of overrun and complexity and problems because the abstraction was not cleanly done. There's a real example of the pain that I went through in that case. So part of making sure these things are cleanly done is the right governance. And in my world, I'm a bit of a geek, so in my world governance is not maybe what you think of it as. I'm very into automated governance. I'm very into trying to make sure that governance is something that happens at the machine level. And I've come up over time with this view that there's a simple way of thinking of this, which is that you need to firstly know what your desired state is. What are you aiming for? And you need to capture that in policy. So policy might be to say that Paul is only allowed to look at his employees' salaries when he's part of the salary review process. That would be an example of a policy. Or another policy might be that no one is allowed to do more than 1,000 concurrent connections to an API at a given time, because we know if it goes over that, it'll crash the back end. And then there is some enforcement as much as possible. Now, some things cannot be enforced directly. Some of those policies can be enforced directly, and some of them can just be observed. But you have some kind of gateway or plugin or part of the system that tries to enforce as much of that desired state as possible. And it also reports to your observability layer. And your observability layer is a combination of sort of looking at what the truth should be and what the actual state of the system is. And these three things give you a view of are we getting to the desired state we want? And you can look at, for example, DevOps systems in this way. So a DevOps system is that you have some unit tests that are your desired state of how you want the system to behave. You have a build process that runs those tests, and you have some observability that says, did the tests all pass or not? So it's not just about runtime things, this also applies, I think, in other places. And this is kind of my problem, is that what I see is that this microservice, this shift to cloud native, has not been followed with the right governance. We have great governance in the DevOps of these individual components. The DevOps processes are awesome, but overall what I see a number of my customers doing is that they've got their legacy system, they've got an integration approach, they're exposing internal APIs, events, and streams out of that legacy, and then they've just said to a brand new digital team, off you go and build whatever you like. So literally, one of my customers has got this integration system as an IBM product, and if you want to get something in there, you have to fill in 40 documents to do it. And at the same time, they've got a brand new team who are off in a brand new office doing digital, writing microservices for Kubernetes in Go, and they can do whatever they like. So I think there's a massive kind of technical debt building up here, which is that this is going to be a real problem. One of my customers told me he'd been doing some work with a bank. They've just replaced 1,500 Kix transactions on the mainframe with probably 1,500 microservices. And he's like, just gone from one mess to another. So, as I say, we're already seeing this proliferation of microservices with no clear structure, no registry, no desired state. The only good thing is actually the observability tools. Some of them are actually much better than we had before. I don't know if you've come across things like Zipkin and Jaeger, Prometheus, and Logstash, but some of these tools are amazing at least letting you see what's happening across this infrastructure. So some of the things are better, some of them are worse, it's very lumpy. One thing that is becoming very popular is something called a micro gateway, which is a control point for these architectures. And what it's doing is that hiding I'm talking about, and some policy enforcement and observability touch point. Another thing in this space is something called a service mesh. And both of these are trying to give some governance and bring something into this space. But my fundamental belief is that we need to move beyond this unstructured mess of microservices, and we need to start creating units of composition. We need to start creating units that you can actually, the CIO can look at and say, okay, I have a customer function, and I have a sales function, and I can build new processes that use those, that I can really treat them as building blocks of my organization. And then we can start to bubble up some of that agility from the lower level. And increasingly, I look into biology for my inspiration. When I was a kid, I hated biology. I loved maths and physics. I was a complete geek, and I found biology too complex and too fuzzy and too difficult. But fundamentally, I think, as an enterprise architect, we can all agree that complexity is our challenge. And biology is full of ways of dealing with complexity. And these are pictures of cells. And what's interesting about cells is, well, partly what's interesting about the cells is the boundary. The boundary of the cell is fundamentally what makes it useful in a way, and what stops us just being a sort of mush of molecules and actually into some functioning organization. And it's the basic structural, functional, and unit of all known living organisms. And I think we might end up going further than cells, but at the moment I would just like some basic structure to our microservices architecture. And so I think what we want to say is that there's a set of deployment, management, and observation that needs to be structured. And within the cell, you can be as agile as you like, but outside the cell, you have to live by rules. And to me, this is kind of a balance between the sort of full-blown agility and the non-agility, and using some kind of gateway or ingress-egress point where you can control the governance, where you can do versioning, where you can do observation, stops people breaking these rules and these boundaries. And so we're beginning to see some of our customers go towards this, and we're envisaging a kind of a view of this sort of cellular organization. It's not really a layered architecture. It's much more of an architecture where you have these components that are say, more hexagonal and freeform, and there's some communication between them. And at least it gives you, you know, Team A may do what the hell they like in here, but they have to live by rules when they talk to anyone else. And sort of see this emergence. I mean, I would characterize where we are today much more as a segmented architecture. So what we've seen is people starting to build segments in their layers that are giving them some control and some separation. But the problem is sometimes these segments are kind of completely freeform, and a future where this cellular architecture is a little bit more of a, gives you some balance between control and agility. And in particular, I think the thing is you can't really get the agility you need if all your integration is centralized. So go on.
Those 3 microservices, or 3 cells with lots of microservices inside.
These are 3 cells with lots of microservices inside them. And some of them are not microservices, so this might be a legacy cell. You might treat a whole legacy component as a cell and hide it behind some kind of API gateway where you have an abstraction to it.
Isn't that in effect the Bezos mandate?
Is that?
The Bezos mandate?
Yes.
The hexagons are routines.
Yes.
You only talk through your API.
Yes. Absolutely. And I'm kind of running out of time, but I guess where I'd like to go is that we've seen the sort of center of excellence emerge as the way of doing integration across organizations. And that's created a kind of massive agility gap, because that center of excellence is fundamentally a kind of waterfall process and has really created a brand new silo. And that decoupling, I think, also needs to be organizational. I think if you can add in organizational decoupling to your functional and physical decoupling, then you can start to get some agility across the enterprise. And that is giving this sort of shift from things like versioning the monolith to having well-defined interfaces by which you can change what you like, from paper and legacy governance to automated bottom-up governance, from complex testing to automated testing and so forth. So this shift is going to hopefully give us a bit more agility at the enterprise level and not just at the project level. And there's my summary. So back to where we started. We're disaggregating our architecture. We need these well-defined interfaces as an abstraction to help us tame some of the complexity, but we also need the right governance. The layered architecture is not really working in microservices and is actually being completely thrown out by the new microservices teams. And this proposed sort of cellular view of the world is going to give us back some level of control, but without hopefully inhibiting the agile approach and actually letting it bubble up a bit more to the enterprise. And I've run out of time, so I'll shut up now. Thank you for the questions, very useful. Do we have time for one more, or are we out?
I'm going to take some questions. In the coffee breaks, we feel free to ask some questions.
Go ahead.
Yeah, I mean, I really like the analysis you've done. Seems to me that the cloud vendors are making this much worse in terms of they're promoting their very stable platform as a way in which you can do all this fancy agile stuff. So Node-RED and other sort of similar Lambda technologies. Yeah. Just munge it all together and you'll get a service. And it looks to be, I look at it and think, well, this is all just hacking up at this level, and there's all the stabilities down at the bottom. What you're proposing is trying to stop that hacking or formalize that hacking in some way.
Yeah, exactly. I'm trying to propose to say, put a bit of structure in it and think about it as units of business units that can be then that your architects can look at and say, okay, I actually have something I can work with here, not just a set of individual components that are out of control. Yeah. So I'm going to I'll come to you. You've asked a few, so Lord.
Yeah, it strikes me as a bit like the Wild West at the moment with all this cloud stuff going on. What in your experience, because you talked about boundaries and these cellular boundaries,
Yes.
what in your experience works there in terms of melding organisational boundaries, systems boundaries, application boundaries and all the rest of it, you know, to take you to the next level in this cellular architecture?
This is kind of very new. So I haven't seen a lot of people. I've seen people talking about this and going there. This is a sort of a continuation of that thought process. I have seen people successfully do much more low-level things. So, for example, in Kubernetes, there's something called a namespace. Everything inside the namespace can chat freely, and then everything outside has to go through an ingress controller or an egress controller. And that's a sort of a technical version. And I've seen some companies use that together with some organizational and sort of governance processes to say, okay, we do have these different namespaces and put it into their platform design and their enterprise architecture. But I've seen a lot more just say, go ahead, feel free. So I think we're still in the Wild West at the moment. Yeah.
Two observations. What do you think? The cells in the body only talk to neighbouring cells.
That's true.
All analogies have a flaky.
Yes.
When you said 200 transactions, 200 microservices, it sounds like it's contrary to the principle that you mentioned briefly, which is that each microservice has its own database. I've heard of cases like this where an application had been decomposed into 200 microservices, and the guy said, we found that we didn't have enough space for the logs, the event logs. He said, this message broker had been sold to us on the basis that we were going to be able to log the business events, so we observe the business events. And he said, it was filling up with thousands of messages, even hundreds for a single transaction, with microservices calling each other and calling themselves.
Absolutely.
And everything going through the event. So the event stream itself becomes problematic when you respond effectively. But you say it's new. Honestly, it sounded like a talk I heard in 1995 at an object technology conference, where the problem was the small size of the object, and the new thing was component-based design. And the only consistent guidance I've heard in the last 30 years is that it's about the bounded context, the domain, the encapsulated data.
So this is not really new. I mean, if you go back to 2001,
the conversation didn't have the data architecture aspect to it.
Yes, I think there's two things that are different. I think so. Firstly, the whole microservices thing. There's an excellent paper in the Communications of the ACM by Werner Vogel's an interview back in 2001 where he basically describes a microservices architecture completely from start to finish, and that's how Amazon built it. So I don't think, I think there's nothing really new, and really all I'm suggesting here is taking the OSGI model, which is a within a VM model, and saying how do you scale that up within an enterprise across things. So it's all about hiding and modularity. So I'm not trying to say this is new. I'm just trying to say that this pattern applied at this level is perhaps new.
I think the most abstract areas are new, but in a way the elements, all the technologies you mentioned are new, and the automating of the monitoring and the policy enforcement.
That is the thing I think that is a change, is that the automated DevOps, the automated monitoring, observability, I think there is a chance for us to iterate on this a little bit better and make it a little bit better. I'm not saying that in 5 years, 10 years' time, we won't all be struggling with enterprise architecture, because we will. But I feel like, my personal experience is I'm a slightly better person than I was 10 years ago, because I've learned that having some organisation to my life makes it go better. And I feel like, a bit of automated governance, a bit of automated DevOps, and some of these processes that constrain us are going to give us a better architecture. And I feel like we've sort of swapped governance in the large for governance in the small at the moment with the microservices, and we need to bring back governance in the large a bit. Right,
Thank you
very much.
Coffee break. So please, thank you.